Hi, my name is Jonathan Repambiza, and from my STEM Pathways project, I chose to focus on recycling 3D plastic filament. At ISK, we use 3D printers for a lot of projects, using filament to create numerous things in our various clubs, such as 3D Fundi. And the use of 3D printers allows us to have multiple iterations for our projects because 3D printers are fast and convenient, and these iterations tend to build up in forms of waste such as drafts, failed designs, rafts, and supports to hold all our models. And all these extra prints end up as waste. My project aims to solve this by recycling 3D filament, and to this project I use the ISK design cycle, which focuses on research and testing to achieve a successful product. So what I aim to do in this project was to create a grinder, spooling mechanism, diameter measuring system, and cooling system for the extrusion machine in the design lab. This should result in a fully functional 3D printing waste recycling system, and it would allow us to create many more prints as they wouldn't go to waste and would actually come back to us and allow us to create more draft prints, and it wouldn't be as wasteful to print iterations. Because there are certain projects that printing in a lighter filament density isn't an option for a print that needs to be tested, such as our wind turbine project. And for this project, it would allow for us to have, in theory, a near infinite amount of filament for iterations. This extrusion line is mainly for the ISK community, but would have far-reaching effects because if we can print far more frequently than our other projects that relate to other communities in Kenya, such as our microscope project in 3D Fundi, would allow us to be way more efficient and cohesive. In this project, I first researched and found other projects to do the same thing, and creating the grinder was the first step in creating the extrusion line. And in this, I first looked at one of the other clubs at our school that uses a grinder and recycles plastic, which is Plastiki Rafiki. They use a simple grinder that cuts plastic into shreds, and I thought we could use the same thing. But ours would need to run slower so it would not melt the plastic and it would not be caught inside the grinder. The idea of a rotating drum would mainly be for bigger pieces of filament so that if the grinder cannot crush this piece, then this rotating drum would crush up the big pieces into smaller, more manageable pieces and then put them into the simple grinder before mentioned. And another idea was the collection drum, which would be an attachment to the simple grinder because it would be a motor spinning on a collection funnel so that as the plastic would come out, it would be collected, move on top of, then shift on top of the grinder, drop it back in. So it could just run automatically for however long it needs. And it could also help for having a more fine material without having to stand there and be present at all times while it runs. The main idea that was taken from the brainstorm was a simple grinder because the others were mainly attachments that could be added on later if needed. And this project will mainly use files from the recycling grinder above, and it's adjusted to suit this project. This model will use the blades from the project, but has a different way of collecting. This is a demonstration of these pieces. And this project has blades inside to cut up the plastic that move like this, and then dropped through this section. Before creating the grinder, we tested different grinders around campus to see whether they would already work for this project, because if so, designing a grinder would not be necessary and we could start on spooling and measuring the filament. After testing each of the grinders, we found that the grinder that Plastiki Rafiki uses melts the plastic because the blades spin too fast and often got stuck between the blades, but the grinder used by the middle school worked almost perfectly and produced well-sized plastic that fit the extruder. After finding the grinder that would fit our needs, we tested the extruder itself, which is a Wellzoom B2 extruder, and it was able to create filament but could not produce at a consistent diameter. To solve this, I thought the spooling could be sped up and slowed down according to diameter measured. And to measure the filament, I modified a caliper to read the values using data pins and showing the readings on a serial monitor. This step was done using this YouTube video. I mainly followed the steps in this and then modified the steps and the electronics slightly. The first idea I had was to have two bearings on top of each other held by a bracket and then have the filament feed through, but since there's no way to measure the filament accurately, there was this YouTube video. This YouTube video shows how to read the data pins on a caliper and then read it into an Arduino, which would then show it on a serial monitor. And from this, I was able to successfully design the project that was used in the YouTube video. So in this, to show the readings, I took an already created spool of 3D plastic filament, fed it through the bearing and the caliper, which you can see over here. And then it shows on the serial monitor on my screen, reading out the different values that it measures at a accuracy of 0.01 millimeters. In this project, the next step is now to create a way to calibrate the caliper, because currently the caliper reads, there's an offset in the bracket that doesn't allow it to read consistently all the time. As you can see here, it shows values between 6 and 5 millimeters instead of values between 0 and 2 millimeters. After this, we should be able to create a program to change the speed of the spooling, and through this, we should be able to finally have a fully functioning 3D plastic recycling system.